Hi. Now one more recurrence relation I will solve. I have not written any algorithm, directly I have taken a recurrence relation and this is dividing function. Tn is divided. I'll solve this using recursion tree method. See Tn, there are two steps in this one. Tn by 2 and n. N is the time taken in this step plus the time taken here also. Then what this will be? This will be taking n by 2 time and also it will be Tn by 2 square. Then what this will be? It will be taking n by 2 square time and Tn by 2 cube. This way I'll be go on reducing. How long? And for k times n by 2 power k times. I'll repeat until here. Then when it is n by 2 power k, I assume that this has become 1 because what is the smaller value I have? N equal to 1. So I assume that I have reduced it up to 1. Now what this will be? If I take these times and add them in each step, so it will be n and it is n by 2, it's n by 2 square and goes on to n by 2 power k. Right? See, the last step will be n by 2 power k, right? See, this is n cube and this is n square. So this will be last will be 2 power k minus 1. So for this something will be there, some function will be there here and it will be n by 2 power k minus 1. And when it is n by 2 power k, it stops. So approximately I am taking it till n by 2 power k or k minus 1 also I can take it. Now let me add all these to get the answer. So this is n plus n by 2 plus n by 2 square plus n by 2 cube plus goes on to n by 2 power k. This will be Tn. What this is equal to? N common 1 plus 1 by 2 plus 1 by 2 square plus 1 by 2 cube plus goes on to 1 by 2 power k. This is n sigma 1 by 2 power I. I takes the values from 0 to k. What is this equal to? This will be equal to 1. Remember this. This will be equal to 1. So this is n into 1. So Tn answer is n. So this is big O of n or theta of n, anything you can say. For explanation, I'll take one circle. And this is half of a circle. This is 1/4 of a circle. This is 1/8 of a circle. This is 1/16 of a circle. If I continue, goes on. So it means 1 by 2 plus 1 by 2 square plus 1 by 2 cube plus 1 by 2 power 4 plus goes on up to infinity. If I add all these pieces, it is equal to one circle. It's one circle. Half, 1/4, 1/8 and all. If you add them up to infinity is 1. So this is approximately equal to 1. So we round it up to 1. N into 1. So it is order of n. So this is one method. Now next method, I'll use substitution method. Now using substitution method, Tn is equals to Tn by 2 plus n. Now if I use this method also, I'll get the same series. In the tree I was getting it vertically and I was adding it. Here I'll get it horizontally. It's the same thing. What is a Tn by 2? This will be Tn by 2 square plus n by 2 and this is n. if I open it, Tn by 2 square plus n by 2 plus n. If this was the first equation, then this is the second equation. I'm not showing here how to substitute and get the next expression, next equation. Already we have done in previous recurrence relation, maybe you have watched them. Next, if I substitute this further, then this will be Tn by 2 cube plus n by 2 square plus n by 2 plus n. If I continue for k times, then it will be Tn by 2 power k plus n by 2 power k minus 1 plus n by 2 power k minus 2 plus goes on to n by 2 plus n. That's it, I am getting the same thing. What is this equal to? This is equal to 1. Tn is equals to Tn by 2 power k plus n by 2 power k minus 1 plus goes on to n by 2 square plus n by 2 plus n. We assume that n by 2 power k is equals to 1. We say that this we have reached till 1, n equal to 1. Therefore, n equal to 2 power k and k is equals to log n. If I substitute this in this recurrence relation, then this is a t1 plus n is a common 1 by 2 power k minus 1 plus 1 by 2 power k minus 2 plus goes on to 1 by 2 plus 1. Then what is this approximately equal to? Tn plus, this is 1 plus n, and this whole thing is 1, and this plus 1 is also there, plus 1. So this is 1 plus 2n. This is big O of n. Now the answer is same order of n.